Good morning, children. Today we will start a new chapter, that is some applications of trigonometry. This is also called as heights and distances. Okay, suppose you are looking a pillar. Okay, you are standing in front of a pillar. Okay, suppose the pillar or a flag post in our school. Okay, or else a building. Okay, anything. It is having some height. Okay, it is having some height. And you are in this position, just away from the pillar, some 100 meters or 50 meters or 10 meters. So you are at some distance between you and pillar. Now, how to find out this height? Okay, usually the length of a cloth or length of the bench or height of the pillar, height of the tower. Okay, how you will measure? With the help of a scale, if it is small measurement. If it is little bigger, you will use tape. Okay, meter tape or 10 meters tape or 50 meters or 100 meters tape, it is available. Nowadays, laser, okay, measurements also coming. With the help of laser, what is the distance between from here to that place? You will apply a laser light where it will stop, then automatically the light, how much travel, this laser light, how much it is travel from the source to the object, the distance will be calculated. But previously, in earlier days, by using trigonometry, we can calculate the height of the pillar without measuring the actual height. Okay? The concept I am explaining. Okay. Now, suppose an observer. Okay. You are an observer. If you are look straight, okay, for certain object, okay, then this line is called index line. This line is called index line. That means this line is parallel to the base. Suppose if I am standing like this, I am looking. Okay, so that means my chin should be parallel to the base and my eyes look straight. What I am observing, look straight. Okay, in a horizontal position, in a straight line position, this straight line should be parallel to the base. Then this line, this imaginary line, what I am observing, this imaginary line is called index line. It is called index line. Some example, I am standing and I am observing a part. Now, if I want to observe on the ceiling a light, or there if I mark anything, if I want to observe that without lifting my head, I should not lift my head. Okay, what is the condition? I should not lift my head to observe that. My chin should be parallel to the ground. If my eyesight is like this, if I want to observe the top, you also observe along with me. Just stand up, okay, look straight, okay, and you can observe what is the object on your eyesight, index line, that position only. Now, do not lift your head up. Your chin should be parallel to the base. Just observe what is there on the ceiling. So, what you did, if you observe the top, what you did, the eyebrows you raised, that means your eyeball is raised and you observe, because your head is, you did not, raise. That means this index line, suppose here it is the object you want to observe without lifting your head. Slowly your eyesight is lifting up. Slowly is lifting up. Then you observe this position. Okay, you observe this position. Then that means this is, if you take this is as initial ray, this is as terminal ray, then this is called angle. Okay, this is called angle. Suppose now, for example, This is your index line. You are observing the object. Now I am doing one more experiment. I am doing like this. Okay, I am standing like this. It is my index line. Now without bending my head down, I should not bend my head down. I should see what is there on the floor. Okay, if it is my head is, if I am looking like this straight, if I want to see down, then what I will do? Okay, so I'll bend my eyebrows, my eyeball, and I will see. Okay, that means this index line slowly, if it is index line, slowly I will get reduced so that it will reach my observation point. Okay, so in this, if it is index line, then this is base. Okay, this is base or horizontal ground, horizontal plane or ground or your floor, whatever it may be. Then this index line should be parallel to this line. Now this is your index line and you observe this object, so your index line slowly get reduced and an angle is formed like this. And angle is formed like this. In these two conditions, one thing is very clear, that is your index line. Here, observation point is above your index line, and here, observation point is below your index line. There are two cases. If I am looking straight, if I observe up, or if I observe down, there are two cases. Okay, if this is called observer, and this is called observation point. Okay, then observation point is above the index line. Then this is called angle of elevation. Angle of elevation. And this is called line of sight. Okay, line of sight. That means what I am observing, it should be a straight line. Okay, this is called angle of elevation. Usually, angle of elevation, angle will be denoted by the letter theta. And here, now this is the observation point. Okay, this is the observation point. And here it is observer. That means you are here, your eyes. Okay, you are observing below the index line. Your observation point is below the index line. You are observing here. Okay, then if below the index line, this angle is called angle of depression. Angle of depression. And you can observe one thing here. Then always this your index line is parallel to the base line. Then this angle is equal to this angle, because both angles are alternate angles. If it is theta, then this is also theta. So we have two cases. One is if I am the observer, if I am observing a point above my index line, then it is called angle of elevation. If my observation point is below my index line, then it is called angle of depression. Okay, only these two concepts are there in some applications of trigonometry. Okay, children, we'll discuss one example now. Okay, look at the question. The string of a kite is 100 meters long and it makes an angle of 60 degrees with the horizontal. Okay, that means it's an horizontal. Horizontal is nothing but a ground or a floor. Okay, now a kite is there. Okay, a kite is there. It is flying at a height, some certain height before the horizon, above the horizon. Now, a string of a kite is 100 meters long and it makes an angle 60 degrees with the horizon. Usually, you will fly a kite with help of a rope and the kite will go like this. Okay? Then, this string is, length of this string is 100 meters long and making an angle of 60 degrees with the horizon. Okay, you are standing here. Okay, imagine that you are standing here. You are flying a kite. Okay, and what is the length of the thread you used to fly a kite? 100 meters long, and it is making 60 degrees with the horizontal. The angle is 60 degrees. Now find the height of the kite. Height of the kite means here how above it is, how much above it is flying above the horizontal plane. Okay, height of the kite means the distance between horizontal to the kite, or how much above it is flying. Okay, if it is considered as h meters. Okay, now you need to find out what is the value of h. So this question consists of, there are total 3 parts. The first one is diagram. Second one is description of the diagram. What is meant by description? Okay, that means what are the values or what is the positions, like C, AC. What is AC? Length of the string. Length of the string is how much? 100 meters. Now AB. Okay, height of the kite or the above horizontal distance or vertical distance, not horizontal, vertical distance. Vertical distance between kite and the ground is equal to h meters. Okay, and the next one is angle ACB is equal to 60 degrees. He gave this is as angle of elevation. Angle of elevation. Because you are here, that means this is your index line. You are observing a kite with an angle of 60 degrees. That means your observation point is above the index line. So that's why it is called the angle of elevation. Now, apply trigonometric ratio here in the diagram. Okay, how? With respect to theta, there will be 2 points always, given RT. What he gave and what we need to find. What he gave with respect to theta, then this is hypotenuse. Good. And with respect to theta, this is opposite side. Good. Okay. With respect to theta, this is opposite side and this is hypotenuse. Now you need to find a relation in between opposite side and hypotenuse. Okay. A trigonometric relation. That means trigonometric ratio. Opposite by hypotenuse is sin theta, or hypotenuse by opposite is cosecant theta. Okay, among two, any one you can use. I am using sin. Okay, sin theta is equal to opposite to theta by hypotenuse. Sin theta, theta is equal to how much? 60 degrees. Sin 60. Opposite to theta, theta opposite is h. Hypotenuse is 100. Sin 60 value, root 3 by 2, h by 100. 2 in 100, 50 times cancel. That means h is equal to 50 root 3 meters. Or else you can use root 3, value is 1.73 or 732 also. Then h is equal to 50 into 1.7. If you multiply, you will get the answer. Or else 5 3 is 15, 1. 5 7 is 35 plus 1, 36, 3. 5 1 5 plus 3, 8. Here already 1 0 is there. Then here it will come around 86.5 meters. So before, that means above the horizontal, it is flying 86.5 meters above the horizontal. Okay.